In this class, we go to the mechanical pressure measurement devices. Mechanical devices offer the simplest mean for pressure measurement. In these sections, we shall examine the principle of some of the more important arrangements about the mechanical pressure measurement devices. The first thing is UTIP manometer. Suppose the fluid manometer is the widely used device for measurement of fluid pressure under steady state and laboratory conditions. Um, Consider the first UTIP manometer given on the screen in the figure 6.3. The difference is pressure between the unknown pressure P and the atmosphere is determined as a function of differential height h. The density of the fluid transmitting the pressure P is Pf. Okay, that is a E beta. P to P of F, and the density of the manometer fluid is designed as P of M. Okay. And the pressure balance of the two column dictates, that is first one P of A plus G divided by G of C, H of P of M is equal to P plus G divided by G of C, H rho of F. In the first things P2 PF I told na, that is P2 PF is the PF is the rho F. Okay, it is the some constant of frequency. So the pressure signal passing through this way, okay, and P of A is measured the location in between the PA to A1, that is the height of H in the UTIP manometer. We give the pressure of the signal here. In the pressure is moving from this direction. Okay, so that part is A2, this part is A1. The location designed by the dotted line. The location is dotted line is the located in the dotted line. If the location of the pressure source is at the different elevation from this point, from this to this, okay, there could be an appreciable error in pressure determination depending on the density of transmitting the fluid here. So then the sensitivity of the UTIP manometer is H. Okay, the sensitivity of the UTIP manometer is H divided by P minus PA is equal to H divided by delta P is equal to 1 divided by G divided by GC into Pm minus Pf. That is the molecular, it is the frequency. The monometer with greater than it is not as it is high than Pf. Okay, Pm is too high than Pf. Okay, so the sensitivity is equal to 1 divided by Pm into G divided by Gc. Here P minus Pa is the measure at the location of the designated for the particular gap in the U-tip manometer. If the location of the pressure source is at the different elevation from this point, okay, that point is denoted by delta P. Delta P is the variation of the pressure range, okay, and the variation of the pressure range denoted by G divided by Gc, okay. That is the range of the sensitivity from from here to here, okay, that pathing, and that is path of A1 to A2, okay, A1 to A2. So in the U-tip manometer have a particular appreciation of error in the pressure determination. That level depends upon a density of the transmitted fluid. Okay, you got the idea now? Okay. The second part is the well type manometer. Here, in the well type manometer operate in the same manner as the U-tip manometer, except that the construction. The construction means it is not fully equal of the U-tip. Okay, and the pressure signal from here, that is A1. So the pressure is passing from here to here. Okay, so here A1 is the first point, then A2 is the height of the range. Okay, so here PA, so the height between the A1 to PA. But in the U-tip, the height between the A1 to A2, okay, or A1 to PA. But here the height of the manometer from A1 range to PA, it is not A2, okay. So this equation seldom used, however, because the height h is not the fluid displacement which is normally measured. Therefore, the pressure balance is P minus PA is equal to G divided by GC H of PM minus PF. Okay. A measurement of well-type manometer made up of displacement of the small column from this zero level. Okay, here this level A1 level is the zero level. So in the zero pressure differential condition depends upon a measurement made up of displacement of the small column from the zero level. Okay, designing this displacement by h dash, the zero level of the designing the displacement by using h dash. So we have in the well type manometer is h dash a2 is equal to h minus h dash into a1. Okay, so h is the height, h dash is the designing the displacement. Okay, so h dash of a2 is equal to h minus h dash into a1. Suppose in the height h is vary, some of the level means that level denoted by h dash. So a2 of that height, okay, height a2 of h dash, small changes of the height is equal to h minus that small changes h dash into a1. Okay, that is equal. a2 of h dash is equal to h minus h dash of a1. Since the volume displacement, okay, the volume displacement are the same on both the side of the manometer. That is P minus PA is equal to G divided by GC H dash of A2 divided by A1 plus 1 into PM minus PF from the UTIP manometer of the P minus PA. Okay, so we have applied A1 A2 of H dash to the P minus PA. And commercial well type manometer have the scale for manometer column graduated so that the user need not apply the area correction factor to the indicated displacement h dash. Okay, and therefore the area ratio of a divided by a2 here, the area ratio of a2 divided by a1 is equal to 0.03. It is the true reading of 10 point for h dash. Okay, that is could be indicated as 10.3 as a result of the special scale gradation. So the indicated value is the substituted for h in equation number where in the equation number p minus pa g divided by gc h of pm minus pf. Okay, so we got this equation. P minus PA is equal to G divided by GC H dash of A2 divided by A1 plus 1 into PM minus PF. Okay. And manometer may be the oriented in the included position to lengthen the scale and to improve the readability or the special optical side classes and vernier scale may be employed to provide more accurate location and indication of the manometer fluid height then could be obtained within the naked eye in the particular side class. When mercury is the manometer fluid means variable uh, that is a variable pickup may be used to scale accurately the fluid height. Okay, the height range is equal to both the side, left side and right side. The special metal fluid may be also fried such a convenience with a less dense fluid, which non-conductive means. For the manometer include an angle theta with a horizontal sensitivity become uh, in the L divided by delta P is equal to 1 divided by P of M minus P of M into sin theta into G divided by GC. That is the angle means in particular fluid mechanics movement, it will create some angle. Okay, the movements of the fluid, it will create the angle. That angle is denoted by sin theta. Okay, here L is measure the fluid displacement along the incline, and H is equal to L sin theta. Here L is the measured fluid displacement with particular angle in the sense of sin theta. Okay. Now consider the two fluid manometer considering of two reserve of the diameter d connected by the U tip of the similar diameter d. Means what happened. So in the T connected by the U tip of the small diameter small d, it is a reservoir. One contain a fluid with density P1, while the reservoir 2 contain a fluid having the density P2. Therefore, the assembly is subjected to the pressure difference between delta P. That is delta P. Okay, that is a ranging. Therefore, the sensitivity may be derived as in the formula. Okay, so the sensitivity may be derived as sensitivity is equal to H divided by delta P is equal to d divided by capital D of the whole square into P2 plus P1 plus P2 minus P1 into G divided by GC the whole inverse. Here H is equal to H initial interface minus H final interface. That is the changes of height. Okay. First reading of the value of height, and final reading of the H. That is called H is equal to H initial interface minus H final interface. When D greater than to small d. Okay. Here capital D is greater than to small d. Okay. And the difference in the two fluid density is small. A very large sensitivity can result by using this formula. Okay, and this situation form the basic for the micro manometer. This calculation part form the basic of the micro manometer. Okay, and last part of the process is the manometer. Here in the manometer, it is a single line with the origins. Okay, here the manometer without U-tube without well type manometer. Suppose just one angle of fluid mechanical pressure to give that manometer means what happened, the absolute of the pressure and the range of the area, that is A1 and A2. Okay, so here in the range of without the fluid, wall is called P is equal to 0. Okay, we apply the PA here. So this level is the A1 and this level is the A2. So the height, it is not, it depends upon A1 and A2. Okay, the height is not, it depends upon A1 and A2. So directly in the range of the height from the level of tube. Okay, the level of the tube. When a well type manometer is arranged by barometer and the top of the column contain the some saturation mercury vapor at the local temperature. This is saturation pressure is negligible in comparison to atmospheric pressure. Okay, therefore the well is exposed to atmosphere pressure. Therefore, the height h is measure of absolute atmosphere pressure. Therefore, P of A is equal to 14.696 Pascal. The height of the column of mercury at 68 degree Fahrenheit. That is 20 degrees Celsius. Okay, could be 760 millimeter. So the column has a graduated scale fixed in the position with the help of some requirement instrument by in 0 for each reading, and the level of the well will vary with the height of the mercury in the column, one column. Okay, the 0 is accomplished with the screw adjustment which set the level of the well at the reference position. So at this point, we should note the many pressure measurement device indicated gauge pressure. Okay, here gauge pressure. So the absolute and local atmospheric pressure involved to this process. Okay, that is the difference between absolute and local atmosphere pressure on gauge pressure. Okay, so to obtain absolute pressure, one must have the course calculated. P of absolute is equal to P of gauge plus P of atmosphere. Okay, ATM is the atmosphere. So pressure of the atmosphere plus pressure of the gas is equal to pressure of the absolute. That concept manometer is processed. Okay. Therefore, P is equal to P naught of 1 minus B is divided by T0 power 5.26. Here, P is the 0.00356 range divided by feet, and Z is altitude, that is the meter or feet. Okay, T naught is Celsius, that is Celsius here 15 degrees Celsius. Okay, so suppose a degree is not measure the device means it is the Kelvin. Okay, that is the temperature. temperature denoted by the Kelvin. Okay, so P naught here, it is the standard atmosphere pressure at the sea level. Okay, it only considered for the manometer of this formula. Okay, so manometer is used for pressure of the atmosphere, and pressure of the cage is assumed as pressure of absolute. Okay, the local atmosphere pressure must be obtained from the local measurement near the place where the cage pressure is measured. Such a measurement might be performed with a mercury barometer. Therefore, local atmosphere pressure can vary between the inside and outside of the building because of ventilator systems. Okay, and the common mistake made by the no voice experimentals is to take the local atmosphere pressure as the value given by the local weather situations. Such practical can be produce major error because the value started by the weather situation is corrected to the sea level using the altitude at the weather stations. Okay, therefore we have calculated by pressure with the help of P naught B is divided by D0. Okay, power 5.26. That's all. So in the pressure measurement device, we discussed U-tip manometer, bell-type manometer, and manometer. Okay, that's all. Thank you.